In today's video, we will solve about the code forces. Okay, so we will see the solutions of code forces round 1055. So I have solved 3 questions. So we will discuss about the solution about the 3 questions only. Okay, A, B, and C. So let's discuss the first question. So what the first question is saying that we have one array. We have one array, this array, and size is given to us. Okay. So we can perform any number of time operations. Okay, there are 2 types of operations we can perform any number of times. Okay, so first operation consists of that increase. We can choose any of the numbers and a of I. Okay, a of I we can choose and we can increase it by any number. Also the second operation consists of that smash. We can smash any number to 0, means like we can change the any of the number to 0. Okay, so all the numbers should be same. Okay, there should be a limited. Okay, so so what the here 2 different numbers are there. Okay, so for 2 different numbers we have to make, we have to make from 0 0 0 to make this numbers. Okay, to make this we will change all of them to 2. After that we will change this 1 1 to make this 1 1. We will change this zeros to 0. We will change this 2 twos to 0. Okay, so after that we will add 1 1 to all of them. Okay, so when we are adding, when we are increasing that, so we can increase any number of numbers. We can choose any a of I and we can replace with that, we can increase the a of I with x. Okay, so the a of I x for one iteration, the x remains same for all of the number, which number we have to increase. Okay, so let's discuss another example. Okay, so we have this one example, this 4355. so what this 4355, we have now 0. So our expected what is this, 3 numbers are there. So my approach is that s dot size into 2, means like the distinct numbers so distinct numbers are distinct numbers is equal to, there are 3 distinct numbers are there. 3 into 2 means like 6 minus of 1. 6 minus of 1 will be 5 number of operations we will require. Okay, 5 number of operations we should require here. Okay, so we have 0 0 0. After that we will take the changes, like you can do iteratively also. Okay, you can sort this array like 5 4 and 3, just like this, and you can implement the distance. Okay, you can replace all of them with the distance like 1. Okay, 1 is the distance here 1 is also the distance here, and 3 is also the 4 minus of 3 is also a distance. Okay, so after this distance has over. Okay, so let's discuss this, what the approach is our 1 1 1. We will change all of them to 1 1 1, like the distance. Okay, distance between 4 and 5. Okay, so distance of 4 and 5 is 1. So we have changed all of them to 1. Okay, after this we have to change this 2's as 0 0. Okay, so this 2's we will change as 0 0's. After this okay, we have changed this to 0 0's. Now after this we will apply the distance here. What distance we will apply? The 4 minus of 3, which is 1. Okay, so 1 1, and this will be 3 3, because we are adding the distance into them. Okay, so 4 minus of 3 is equal to 1. So for this, okay, now 1 1 3 3 we have. After this 1 1 3 3, so we have to make 3 as 0. Okay, so we have to make 3 as a 0 when 1 is only required. When 1 is only required, so we have to make this as a 0. Okay, so now 1, here is 0, here is 3, here is 3. Okay, after this 3, so we have now applied the 4 operations. After this only one operation is required now. Okay, only one operation is remaining now. Okay, so the one operation is 3. We have to increase this by 3, so 0. We have to increase the 0 by 3, so we will increase all by 3. Okay, we will increase all of them by 3 3 3. Okay, 1 1 and 2 2. Then we have increased it by, okay, 1 1, okay, 0 0 and 1 1. Okay, sorry, here we have messed up some. Okay, here should be 1 1 is present. Okay, that's why I'm saying that what is the, yes, okay, so now it is correct. Okay, so now when we increase all of them by 3, so we will get the 4, we will get here 3 5 and 5. So this is our this is the 1, this is the 2, this is 3, and this is the fourth operation, this is fifth operation. So the operations, the number of operations we will require is like s dot size means distinct number of numbers present in that array into 2 minus of 1 we will require. Okay, and this will pass on all the test cases. Okay, so let's see this second question. Okay, so catching the king is like okay, so here okay, you have to read the question before watching the tutorial. You have to read the question. If you are able to solve this question, so you should do it by yourself, and if you are stuck at any of the places, so you can watch this tutorial, and if you get any of the intuition behind between the tutorial, so you can leave the tutorial and you can solve it by yourself. Okay, so let's see the okay, what the question is saying, that here is a Krug is there and Doran is there. Okay, Krug and Doran, you can make it like that, rename them as this is the police, this is a chore. Okay, this is a chore and or the thief, and this is the police. Okay, so police can go in this all the 6 directions, 3 3 6 and 8. Okay, so all the 8 directions he can displace. Okay, just like the queen. Okay, and here in this like thief can walk by like the that elephant which is in the chase. Okay, elephant, like the elephant, he can run in the only 4 direction, which is left, right and down and up. Okay, so these are the only 4 direction he can go. Okay, now what are the here what is the output required, that we have to figure out that how many most of the number of like moves we can do, so that the maximum days the thief can be thief cannot be in the hand of the police. Okay, so the police cannot catch the thief the maximum number of days. Okay, so on every day the thief and the police will will be displaced from their position to or on their position only. Okay, the maximum number of days that can be there. Okay, now there is a police. Okay, police is there and thief is also there. Now they have to move them from their places now. So the maximum, the intuitive, the greedy solution for this will be that if K is on the left of the police, means like thief is on the left of the police, police is on the right of that thief. Okay, so thief will go on to the left part. Okay, thief will go to the left. Okay, but here none of them is present now, none of the remaining places are there on the left, so he cannot go on the left, and on first day only thief will be caught by the police. Okay, now thief is on the upper side of that police, so he will go to the upper side, because if we try to come down, so it will be caught by the police, okay, on that day only, okay, on first day only. So he will go on the top, again on the top, okay. If that thief is on the top, he will go on the top. If the thief is on the left of that police, so he will go on the left of the police again, okay. Again, if thief is here, like down of the police, so he will go down. If thief is on the right side of that police, so he will go to the right side only, okay. So that's our approach, that is the greedy solution for this question, okay. Just like there here, okay. So thief is here, so thief is the down to the police, so he will go down, okay. There are three remaining places, so he can go to the 3 here, or 1 2 3, okay, 3 here also. But when the thief go to this side, so he will be caught by the police, okay. So he cannot go to that, so there should be that K should not be present on the column of police, okay. So it should be greater than, or it should be less than, it should be greater than the, okay, it should be greater than the greater than or less than, okay. It cannot be equal to, okay, means like it cannot be at his column, at his rows also, okay. So now the maximum the thief can be छुप के बैठ सकता है, so means like thief cannot be able to catch, okay, so police cannot be able to catch the thief. The number of days, the maximum number of days will be 1 2 and 3. So police on first day come to here, but thief come to here, this position, okay. On second day the police come to this position and thief will come to this position, okay. On third day the thief the police comes to this position, and the thief wants to go here, or left side or right side, but he can be catched because the police is here, and police will go on the next day, police will go here or here, okay, and the thief will be caught. So the maximum number of days it can be like hidden, the thief can be hidden, is like 1 2 and 3, okay. So the answer for this will be for the second test case will be the 3, and for first test case it will be the 1, because on first day it will be caught, okay. So the solution for this will be, okay, this is the solution, that K1 K2 and D1 D2, so we can consider them as this is a thief's coordinates, like K1 represent the row and it represents the column. This represents the police row and police column, okay. So you can rename them as also, okay. Again, so we doesn't have use here less than or equal to, we doesn't have use, because equal to, at the equal to position it cannot be able to run outside, because it will be caught on the first only, okay. So we have to find out the maximum it can run, okay. The thief can run maximum how much cells he can run, okay. So he can run any of them, but the police can we have to find out the police in how much iterations the police can catch him, okay. So these are the rows or the columns which the police can catch him, okay, in which the police can catch him. So these are the coordinates, okay. So if both of them, means like if both of them is not able to catch them, means like okay, so in at any time, so when it is equal to, means like if any of the coordinate, like if it is same on the x or same on the y axis, so it can be catched out, okay, catched by them, okay, it can be catched by them, okay. Means like both of them, means both of them at the same place, so the thief can be replaced in on the other cell, thief can go on the other cell, but the police will also come back to that cell and catch in the first iteration only, or in the 0th iteration only. Okay, let's see the third question. What our third question is a triple removal. Okay, so it's somewhat like nearly 1500 problems. Okay, 1500 rating. So what this saying that triple removal. Okay, so yes, this is the triple removal problem. So it can be removed when this is the triple removal problem. So what the triple removal problem is, like, we can remove 1 1 and 1, this 1 1 and this one. Okay, so we can remove this 3 ones at a time. We can remove this zeros means same number of zeros, or say the number of zeros or number of ones, the only 3 we can remove at one time only. Okay, so we have to find out that how much minimum number of cost we will require to remove them all. Okay, so the minimum cost will be like the cost, the total cost, the cost of this operation is defined as the minimum of k minus of j minus of I. So minimum from both of them, and we will add all of them cost. Okay, all of them cost. Okay, all of them cost. Okay, hello. Yes मैम बोलिए. हाँ यस मैम बोलिए. मैम आई एम इन 4th year, final year. Okay, so ma'am, which company it is? Okay, ma'am. So in my in this internship, what job role will be allocated to me? Okay. Okay, so ma'am, for the training and internship, do you have any charges?
Yes, so there will be some basic amount to be paid for the training and internship, which includes 1 month of training, projects, and post the 2 months of training and projects, you'll be having an internship. Okay.
Okay, ma'am. But what are the charges for that training?
So the 2-month training charges will be 3,000 rupees.
Okay, ma'am. But I am not able to give the charges. So sorry for your time. Thank you
So
very
this is
much.
not related to that, Girish. This is actually, we are offering you a campus ambassador role.
Okay, ma'am. But I am not interested in that role.
Okay.
Sorry very much. Thank you. Okay, so it's very disgusting, guys. So if you get this types of calls, so ignore them, because this campus ambassador role is like very bullshit. Okay, yeah, and this you will give them any type of money, and they will doesn't provide any of the training. They will only provide you the lectures, which can be available on the YouTube as a free sources. So you can go and watch this on YouTube only. Okay, so let's come back to our question. What our question saying that? Okay, so minimum from k minus of j and j minus of I. So these are this indicates, the k indicates the third index. Okay, because we have to choose the 3 numbers, so we can choose the 3 numbers, and k is the indices of the third number, j is the indices of second number, I is the index of first number. Okay, so this is the difference between that all the indices. Okay, difference between the indices, this the indices which are concurrent. Okay, concurrent indices we can say. So we have to find out the minimum distance between them. Okay, So the maximum distance we can arrive, okay, the maximum distance we can arrive when we have the iterations like 1 0 1 0 and 1 0, okay, 1 0 1 0 1 0. This is the time when we arrive the maximum cost, okay, because we cannot choose, okay, but because here we, if we choose 1 1 and 1, okay, or we can choose 0 0 and 0, so we will have to pay the cost as 2, because this distance, this 0 and this 0 distance is also 2, this 0 and this 0 distance is also 2, so the minimum from both the distances will be 2. So at anyhow we have to pay 2 distance or 2 cost, okay, but we have to minimize that cost. So what we will choose, we can choose 1 1 and 1, but here it also we will have to pay the 2 cost, okay. So at any time if we come across this type of any of the sequence, so at this time we have to pay 1, okay, plus 1 cost, okay, plus 1 we have to pay, just like in this example, like yes, this example 5 to 10, okay, the 1 2 3 4 and 5, so from here to like 10 like here, okay, so here to here we have 0 1 alternating sequence. If we have the alternating sequence here, so we will have to pay 1 plus cost, okay, means like the cost which we have plus 1 we have to pay. Now at any time what will be the cost for, okay, if this sequence doesn't we doesn't get this type of sequence, so what the cost we will make, okay, we will need what the type of cost we will need. So the type of cost you will need like 0 0 0 0 0 0, means like one sequence, here it is one sequence, 0 0 and 0, here it is second sequence, 1 1 and 1, here it is a 3 sequence. So third 3 sequences we have got, okay, so we have got the 3 sequences. So the cost for this sequence will be 3, okay, but we have at first time we have that removed this sequence. After removing this sequence we have got this sequence. So after performing the operations on this sequence we will get the cost as a 3, that's 1 1 and 1, okay. After that here are 4 sequences, okay, so 0 0 0 one sequence, 1 1 and 1, this we have done with the 2 sequences, 0 0 and 0 we have done with the third sequence, 1 1 and 1, so we have 4 sequences. So our total cost will be the 4, okay. Now in this case if any of them, means like any of the that double iteration is not present here, okay, so we can mark this double iteration as this, okay, 1 1 0 0 or 1 1, okay. If any one of them is present, so it can be like 4, means number of operations which is required to decrease them, okay, means like number of zeros plus number of ones divided by 3. So these are the number of operations which we will require when there is any one of them consecutive 1 1 is present or consecutive 0 0 is present, okay. If there is none of the consecutive 1 or consecutive zeros are present, so means like we have the sequence like 1 0 we have the sequence like 1 0 1 0 1 0, okay. If only this much of the sequence we have present, so we have to add, means like we have to plus 1, we have to answer plus 1, okay, means the required value will be plus 1, because the minimum operations will be 2 and 2, okay. So 2 and 2 we will be required, okay. So for counting this we have to make the prefix, okay, to count the number of zeros or count the number of ones, okay. If we have not able to count that also, so because we have to count them, because there should be condition like this, okay, there should be condition like this, means like the number of zeros cannot be divisible by 3, or the number of ones cannot be divisible by 3. So at that time we cannot able to decrease them. Okay, so at that time we will return it as a -1. Okay, so let's see the code for it. Okay, so here it is a array arr, prefix 1, prefix 0, prefix map 1. Okay, map 0 and map 1. So map 0 and map 1, what the map 0 and map 1 is preventing, that this prefix 1 and prefix 0 is taking the count of that zeros, how much count has been done. Okay, this prefix map has you can optimize it again, but I have solved it like this only. Okay, so this is the prefix map which is presenting that how much that consecutive ones are present or not there. Okay, consecutive ones, if consecutive ones are present there, if consecutive ones are not present there, so we will increase. So when we decrease the left minus of right, means like here. Okay, so when we decrease the left, okay, prefix map 0, prefix map 0, right minus of 1 and left, so we will get that if they are all equal, so means any of the consecutive one is present there, means like any number of singles. So there is a consecutive one is present when the prefix have only count 1. Okay, when the prefix have only count 1, so that the number is increasing. Okay, the consecutive numbers are present there. Okay, so this is our logic. And yes, okay, we have count here the prefixes means like a zero, count of zeros, we can make it rename them as a count of zeros and count of ones there. If it is present there, so we will increase them, count of 1 and count of zeros. Okay, there is a map. Okay, that count is increasing, that how much it is increasing. Okay, if anyone has increased, like if there is a 1 1 and 0 and 1. Okay, so the count of 1 is like count of 1, what will be the count of 1? Okay, count of 1 will be the 1, here it will be 2, here it will be 2, and here it will be 3. Okay, so now the count of 1 means like if there is a consecutive ones are present, so the count of 1 will be 1. Okay, the count of 1, its occurrence will be for only 1. Okay, its occurrence means like its frequency will be only for 1. Here 1 0 is there, so its frequency is greater than 1. Okay, if it is again 0 is present, so again 2, the count of 2 will be increased. Okay, now here the 1 is only present at for only one time, so the 3 occurrence is only for 1 time. Okay, if there is a 1, so its occurrence will be only 4, and 3 will be only for 1, so it will be also counted in the map array. Okay, map. So this is the prefix map, which where we are storing them, and we are if its count is 1 only, so we are counting is like a prefix map. Okay, so the prefix map, what the prefix map of 1 is counting this. Okay, so prefix map of 1 is counting like, okay, this is the 1, here 2 is present multiple times, so that's why there will no changes. Here 3 is occurring for only 1 time, 4 is also occurring for only 1 time, so this will be our prefix map array. Now when we are adding for this, like 1 is present here, and here it is also present. Okay, so 3 minus of 1. Okay, so many of the consecutive means like consecutives are present, like 1 1 and 0 0 also is present. Okay, 1 1 again it is present, so 3 minus of 1. Okay, means like 3 minus of 1 means like 2 consecutives are present here. Okay, 3 consecutives are present there, so 3 plus of 1. Okay, if any of them is not present, like 0 1 0, okay, 0 is there. Okay, so we have to remove them. Okay, count of 1 we will count. Okay, so 0, 1 2 and 2 and 3. Okay, now its count, we will count them. Okay, means like 1 1 2 2 and 3 is here also. Okay, so all of them are there and we cannot prevent them. So that's why if its count is already map of then map means like count, their count is equal to 1, so then only we will increase, otherwise it will be 0, it will be 0, it will be 0, it will be 0, and it will be 1. Okay, because 3 count of 3 is only 1 for 1. Okay, but now for count of 3 we can add them. Okay, so now for count of 1, okay, we can have this one iteration as this and this. Okay, so that map will be counted initially, so it will be taken this also into consideration. So this 3 having the 3 3 and this will be 1. Okay, 1 again. Okay, but we have to consider for only this much only. Okay, the left portion of this. Okay, left portion for this means this much only we have to consider. So that's why we will neglect this. Okay, and we will consider for this much. Okay, that's why we have added here r minus of 1 up to the l. So this should be equal to, it's like this to this. Okay, if this and this are equal, so and this is for the 1, this is for the 0 and this is for the 1. So for both of them, if that condition matters, if that condition satisfies, so we have to increase it by only 1. Okay, and we have to push back, or we can see out here also. Okay, and that's our solution for the C. Okay, so I will try for the D. Okay, if I got the solution, I will post my solution into the description. So until then, goodbye, and we will see you in the next video. Until then, goodbye. Thank you.